Everyone, today we are going to see about find the solution using the Ogle's approximation method and find the optimal solution using the Modi method. So A and B, C and the availability and requirement are given here. So we have to find the initial feasible solution using the Ogle's approximation method, that is A, B, C, D, E, F, G. Based on the availability and requirement, we have to plot the occupied, we have to find the allocations. So consider this, and we have by using the Ogle's approximation method, we have to choose the least two numbers, and we have to subtract and put the numbers. So here 11 and 16. So difference is 5, and that 18 minus 13 is 5, and here 14 minus 13 is 1. And if we have the same number, we have to leave that number, leave any one of them and take the next term which has the least value compared to the first one. So 14 minus 10 is 4, and 13 minus 10 is 3, and 14 minus 10 is 4, and 14 minus 11 is, sorry, 13 minus 11 is 2. So we have to pick the highest difference. So here highest difference is having 2. We can choose either this term or this term is our wish. So I take this term and I put compare the availability and requirement. My requirement is 200 is less than the availability, so I choose the 200 and placed here, and this term goes to 0, and this term, the balance term, consider here having a 50. So I there is no rows in here, so I crossed out these terms. So then I have to find the difference. Here 18 minus 3 13 is 5, and here as it is, and compared to this also 4, and this is 13 minus 10 is 3, and 14 minus 4, and here 13 and 14 difference is 1. So highest term is here 1. We have to choose the least number. So comparatively, I picked that as here the least number is 13, so 50 is goes here, and if we take 15 means 175 is the balance term. So this term goes out, and the next allocation how we choose means based on this having no terms, and here 18 minus, sorry, this term goes out, and 18 here is 4 plus 2 6, and here 1, this term goes out, and this is also nil, and whatever I consider here 3, then and 4, this term is goes out. So highest term is 6, compared to this the least number is 18, so I have to substitute 175. So I substitute 175 means the balance term is 25 plus 100, so 125. Okay, then what I do means this term goes out because I substitute all the terms, all the requirements. And then what should I do means again I pick this, and the difference is 1. Here is here it is 4. Yes, here it is 4, and here is 3, 4, and nil. So highest term is I having 4 either on side. It is our wish what I choose. So I pick this term. So I substitute 1 to 5 here. This term goes out, and this term goes out means what is the balance terms? So here having 75 plus 50. So the balance term is 75 plus 50, which is 125. So the balance is 125 here. So then what I do means I cross this terms because it goes out, and the final terms balanced here is this goes out, this goes out, and here is 13 and 10. Here is 10. So based on my requirement, I pick this. So I have to substitute either this term or this term. Consider the least. So I pick this term. So I substitute 125 means the balance term is nothing but 275. So 275, which means here also 275. So I substitute means this 2 goes out. So what is our answer is 200 into 11 plus 13, 200 into 11 plus 13 into 50 plus 175 into 18 plus 275 into 13 plus 125 into 10. Okay, 1 2 3 4 5. So I get 1 2 3 4 5. So I get 1 2 3 4 5 terms. So the final answer of mine is of initial basic feasible solution is feasible solution by Vogel's approximation method is nothing but 12,075. Okay, this is my answer. If I do the all the calculations means I get this answer. So this is the way we have to solve to solve optimal solutions based on the Modi's method. So if we want to do the Modi's method, first we have to find the initial basic feasible solution based on the Vogel's approximation method, and then only we have to find the solution using the Modi's method. So Modi's method is nothing but, so consider this term, and what we do means we have to optimal test using Modi's method is nothing but we have to choose these terms, and we have to put a 0. So we have to find the terms that are feasible solution. Okay, so what we do means we choose the maximum number of occupied cells. It's all the rows having two, so two occupied cells. So choose whatever you want to. I pick this one, u1, u2, u3, and v1, v2, v3, v4. Okay, I pick this, and I substitute to get this answer. I have to substitute here 0, so it is based on. So if I substitute means occupied cells, we have the form that is ui plus vj equal to cij. That is nothing but u1 plus v1 equal to cij. That is nothing but 11. So if I put 0 means the v1 will be surely 11, which means only u1 plus v1 will give 11. Okay, then based on here I have 13. It is only for occupied cells. So how to find the next other terms means compared to this 18. So if I which means 18 equal to 13 plus u2, which is nothing but u2 is nothing but 18 minus 13 is 5. So if I get 5, u2 means we get 13 here. So based on this 5 plus 5 only we get 10. So our v4 is 5. Okay, then next what else we have? v3. Okay, and u3. So based on the u3, if we have 10 here means what is the term happen to be here? That is also 5. So 5 plus 5 only 10. And then what is the else term required to find us? u3 plus v3 will be 13. So I have 5. What is the terms I require to be? That is nothing but 8. So I find all the solutions based on the optimal test using the Modi's method by the formula of ui plus vj equal to cij, and I substitute that u1 equal to 0. So what I'm trying to say is we can easily find the solutions by using a Modi method based on the occupied cells. So for that occupied cells only we have to find the least cost method or northwest corner method or Vogel's approximation method. The best method according to this is Vogel's approximation method. It will give the precise answer according to our solutions requirements. So I find all the terms. Then what should I have to find means I have to find the unoccupied cells. So find del ij for the unoccupied cells, which means del ij minus zij minus cij equal to ui plus vj minus cij. Don't get feared. So we have to find the optimality. So the optimality test might be that might less than 0. So what should I am trying to say means we have to find the optimal unoccupied cells. Okay, del ij is nothing but compare this. So here is the formula is ui sorry uh, ui plus vj minus cij equal to del ij. Okay, so what is our 17? 17 is my 17 is my form, which is for this we have to put, so u, what is this, u1 plus v3 minus 17 equal to del first row and third column del 1 3. So what is our u1 is 0 plus v3 is nothing but 8 minus 17 equal to del 13. So our del 13 is nothing but minus 11. Okay, our del 13 is nothing but, sorry, 9. Okay, del 13 is nothing but 9. Then for all the term I have to find the del ij. So for del 14, what is del 14? 5 plus 0 minus 14 is nothing but 9. Then del 21 is nothing but, del 21 is 11 plus 5 is 16 minus 16, that is 0. It is less than or equal to 0. So then 8 plus 5 is 13, that is 14 minus 13 is, sorry, 13 minus 14 is minus 1. Then 11 plus 5 is 16. 4 plus 1 is 5, so minus 5 is our answer. And for del 3 2 is nothing but 13 plus 5 is nothing but 18. 18 minus 24 is 6, minus 6. Okay, so for all the del, for all the occupied cells, to find del ij for all occupied cells in ith row jth column, where del ij minus zij minus cij, which is nothing but ui plus vj minus cij, will be less than or equal to 0. So it is a current feasible solution, is an optimum one. So our answer is all the optimal, all the, it will be, the solution will be feasible. So we have to take the occupied cells into the cij term, that will the minimum total transportation cost. So hope you all understand, and thank you.